there are three very important properties of the oceans, three important physical properties: the density of the ocean waters, the temperature of the ocean waters, and salinity. Now, these three properties are interrelated and they decide many aspects of the oceans: how the water circulates, which part of the oceans are warmer and which are not, decides what type of marine biotic environments we have. This distribution also decides how effective are the oceans in heat sequestration and carbon dioxide sequestration. Warmer waters generally absorb less amount of carbon dioxide. So there are a lot of relationships that we have that decide how the ocean environment functions and operates. Now, as a part of your syllabus and optional, I'm sure all of you have studied enough about salinity and temperature. You know about salinity, what are the factors, what are the patterns, and some of you would have also practiced drawing the isohalines. So salinity is not the discussion point, and temperature too. Of course, temperature of the oceans are related to the atmospheric temperatures. If you have the isotherms for the atmosphere, you also know more or less what kind of temperature do we have on the ocean surface at least. So these two concepts invariably all students know, but the density is something not many of us study. Again, one of those peripheral areas. If you can listen to this video patiently for 10-15 minutes, you'll have enough content to answer a question around density. Okay, so the discussion for this video is density of the seawater or density of the oceans. Now, seawater is denser than regular pure water, and the density on an average is around 1.028, though we have gram per cm cube, but because you compare with water, we keep it dimensionless or unitless rather, and therefore it is 1.028. That's the average density of the ocean waters. Now, the problem is to express such a big number sometimes becomes tedious. So what we have done is they use a symbol called as sigma. This is the sigma symbol. Sigma is expressed as the density of the oceans minus 1 into 1000. So what we are doing is we are trying to reduce the number to some convenient number. So we want to reduce the number to some kind of an easily memorable number rather than 1.028. So what we do is when we subtract 1 and multiply 1000, we get a number like 28. And this is called as the sigma value. So it more or less represents the density of the oceans. So imagine the sigma value is 23. The density is 1.023. If sigma is 29, the density is 1.029. Okay, so sigma value is just a convenient way of expressing the density of the ocean waters. So this you can express in a paragraph. The next discussion is what are the factors that control density of the waters. The three primary factors are temperature, salinity, and pressure. Now, the pressure dimension or the factor is generally not discussed much. Why? Because for all practical purpose, water is considered to be incompressible. You go down the depth, you go along the water, the pressure does increase. Okay, you have the formula of H rho g, okay, how the pressure increases, the hydrostatic pressure. But this pressure does not really result in compressing the water much. For all practical purpose, water is considered to be incompressible. So in that sense, the density does not really change with pressure. So you may very well ignore this. So what we are left with is two factors that decide temperature and salinity. So the relationship is density is inversely proportional to temperature. So when the water is warmer, the water expands, the density will be lesser. When the water is cooler, the water kind of contracts, of course, within and more than 4 degrees centigrade. So when water becomes cooler, water will contract and the density therefore become higher. Whereas for salinity, the relationship is positively correlated. More salinity, more dense; less salinity, less dense. But the problem with the oceans is that temperature and salinity act together. If temperature was not in consideration and density dependent only on salinity, I would have had this relationship. If salinity not in consideration, I have only temperature, I would have had this relationship. But in reality, temperature and salinity act together. So at any given time, it is possible for water to be warm but dense. It's possible for water to be cooler but lighter. If you recall something about the circulations in the ocean, in the enclosed seas like Mediterranean Sea. The Mediterranean Sea is warmer, but it has more salts, so the surface water sinks because of salinity that makes the water more dense. So my point is, when two factors act together, you cannot judge on your own what will happen to density, because in some areas temperature decides density, in other areas salinity controls density. So this could be one of the discussion points in your answer on density. And finally, what is the vertical pattern of density? The ocean waters can be divided into broadly 3 layers. And I'll suggest you remember these 3 layers even for temperature and also for salinity. There is a superficial layer in the photic zone within around 200 meters. There is a transition layer till around 1000 meters. And thereafter, this is relatively deeper waters. So I'm giving you convenient numbers. This is around 200 to 300 meters. This around 1000 meters. And thereafter we have the deeper water. In the surface, the waters are warmer, warm water, and therefore less dense. The deeper waters are cooler, and this cold water is dense, and therefore this is a high density water. And in some other video we'll discuss how this water becomes part of what's called as deep water masses, whereas this intermediate layer is like a transition zone where the temperatures fall rapidly with depth, where the density also changes rapidly with depth. In the context of temperature, this is called as a thermocline. In the context of salinity, the transition zone is called as the halocline. And while discussing density, we call it as the pycnocline, Pycnocline. So what is the average value of density? How do we express it? As sigma. What are the factors and how are they correlated? What's the pattern of density through the depth of the water? Though all these discussions are in Savindra Singh in the chapter Physical Properties of Seawater, but I'll suggest you need not read this from the book, though I can suggest the pages to you if you are still curious. Okay, this is chapter number 4. You can read up from page 105 till the end of the chapter 110. But I think more or less this is a nice summary of the discussions around density. So you could attempt a question which would be worded like, discuss the factors controlling density of ocean waters and what is the vertical pattern of density. I repeat, what are the factors controlling the density patterns of the oceans, and discuss the vertical pattern of density. Thank you.